This video tutorial will take a look at solving a quadratic equation by completing the square. Let's solve the quadratic equation 5x squared plus 15x equals 27. In this quadratic equation, we have an a value of 5. When using completing the square as a strategy to solve a quadratic equation, we cannot have an a value other than 1. To take care of this, we will divide by 5. What we do to one side of an equation, we must also do to the other side. Simplifying the left side, 5x squared divided by 5 is x squared, and positive 15x divided by 5 is positive 3x. On the right side, 27 divided by 5 is 5.4. By dividing by 5, we have taken care of our a value, so we can move forward with the strategy of completing the square. When using the strategy of completing the square, we need to have the ax squared and the bx terms alone on the left side, which is already the case in this example, so we can move forward completing the square. To complete the square, we will take half of our b value, which is 1.5, and square that. 1.5 squared is 2.25. So we will add 2.25, and this will complete the square, making the left side of our equation a perfect square trinomial. What we do to one side, we must also do to the other side. 5.4 plus 2.25 is 7.65. Now that the left side of our equation is a perfect square trinomial, we can factor it as such. It will factor as x plus 1.5 squared. So our new equation is x plus 1.5 squared equals 7.65. We now have to take care of the square on the left side of the equation. To do this, we will square root. What we do to one side of an equation, we must also do to the other side. On the left side, the square and the square root will cancel one another out, leaving just x plus 1.5. On the right side of the equation, the square root of 7.65 is approximately positive and negative 2.77. Now, it will be important to break this down into two separate equations. X plus 1.5 equals positive 2.77, and x plus 1.5 equals negative 2.77. Solving our first equation, we find that x equals 1.27. In solving our second equation, we find that x equals negative 4.27. So we have our two solutions, x equals 1.27 and x equals negative 4.27. Let's check our two solutions in our original equation for accuracy. We can do this by substituting our solutions in for both x's in the original equation. It will be important to note that our check will not work out exact because we took the approximate value of the square root of 7.65. Let's start by plugging our first solution, 1.27, in for both x's. Now that we have substituted 1.27 in for both x's, let's simplify according to order of operation. First, exponents. 1.27 squared is 1.6129. Then multiplication, 5 times 1.6129 is 8.0645. Still with multiplication, 15 times 1.27 is 19.05. And adding these two is 27.11. which is very, very close to 27. And as mentioned earlier, it will not come out exactly because we took the approximate value of the square root of 7.65. So our first answer checks out. Let's substitute our second solution, negative 4.27, in for both x's. Now that we have substituted it in for both x's, let's go ahead and simplify according to order of operation. First, exponents. Negative 4.27 squared is 18.23. Multiplication next, 5 times 18.23 is 91.15. Still with multiplication, 15 times negative 4.27 is negative 64.05, and 91.15 plus a negative 64.05 is 27.1. Again, very, very close. So our second solution checks out. The two solutions to this quadratic equation are x equals 1.27 and negative 4.27.